Good morning, students. So yesterday we started a topic called dual nature of matter, right? So in yesterday's class, we discussed about the de Broglie's theory. Okay. So why it is light is of having dual nature. So one is particle nature as well as wave nature. Okay. So continuation further. So what we have seen about the energy of the photon, we have seen the momentum of the photons, right? So what is the final equation we got for energy? It will be 12400 by lambda in angstroms, and the energy will be in electron volts. And the properties of the photons we have seen. Okay. So today continuation of the about the photons we'll see for a while, and then we'll start photoelectric effect. Okay. So about the photons. How to calculate the number of photons. Try to understand the point. Yesterday we studied about the energy and the momentum of the photons. That's it. So today, for example, try to understand this, the continuation of the yesterday's topic. We'll try to close that within 10-15 minutes, and we'll start photoelectric effect. Okay? So yesterday we considered the photons, right? So photons. Now I'm trying to calculate the number of photons. Trying to calculate number of photons striking per unit area. Number of photons striking per unit area. Important concept, so that's right. Okay. So consider for example photons striking the surface. Assume this is the surface, interface of the surface. Interface. Okay. So these are the photons having intensity I. Having intensity I, having frequency F, and having speed, assume C. Speed of light, already we studied the properties. Speed of the photons, which is nothing but speed of light, and photons having the frequency I am assuming it as F, and intensity is I. And striking the surface, that area I am considering as A. Okay, so photons are coming. There is a source. Photons are coming and they are striking the surface. Assume this is the surface. Photons strike the surface. How much area it covered? So when striking the surface, up to how much area the photons are striking? That is nothing but A. A is the area where the photons are striking. Okay, so now what to calculate? Write the question. Find the number of photons striking the given area, A in T0 seconds, or any second you can take, 1 second, 2 seconds, yes or no? Say 1 second. So for example, consider a photon. So 2 photons came and they strike the surface. So for example, in 1 second. Next second, so number of photons will be increased, right? It depends on the time. If time increases, number of photons striking per unit area increases. Clear? So if time increases, number of photons striking per unit area increases. So how to calculate that? So we know a formula. I think in 11 waves we studied a formula for intensity, and in double slit experiment also I think we will get this formula. Not 100%, but waves will get. So intensity I can write as power per unit area. Try to understand the point. We can apply in waves concept also. This is also a wave, right? So we can apply in waves concept. So intensity, which is equals to power per unit area. So power is nothing but energy per unit time and area. Right? Clear about the point? Intensity, if you want to calculate, that is nothing but power per unit area. Power per unit area. So how you can tell like that? Try to come back to an example. So consider a bulb is here, a point source. Assume a bulb. Okay? Assume a bulb is here at this point. Okay? So if a bulb is there, what will happen? So the waves will go in all the directions. Already we studied. If the source is there, from the source in all the directions, the rays will go. Already we studied in the wave optics, wavefronts, spherical wavefronts we can form. Okay, so I consider a source. Around that, what will happen? Can I draw a spherical wavefront? Okay, so one more wavefront also I am considering. Clear? Try to understand this concept. Okay. So now a source is there. So I consider the two wavefronts, spherical wavefronts. Now what I want to get from this example is find the energy. Try to understand all the points. So I am treating it as a question, but generally it is a concept. Generally it is a concept. Okay. So if I discuss it is like a question, then you can understand it more. So that's why I do it as a question. Okay. So a source is there. Clear about the question? A source is there, and I formed two wavefronts of different radius. So assume this is R1 and assume it is R2. If you want, you can consider R1 and R2 radius. I consider one more wavefront, spherical wavefront. Okay. So now what is my question is find the energy. Find the energy on the two wavefronts. Find the energy on the two wavefronts by the source. By the source. Find the energy on the two wavefronts by the source. And next point, find the intensity. Find the intensity again on the two wavefronts. What will be the intensity of the light on the two wavefronts? What will be the energy falling on the wavefront by the source? Is that clear? How much energy falling on the wavefront by the source? Those two things you have to understand, right? So energy on the two wavefronts, energy on the two wavefronts will be same. Can you understand the points? Energy on the two wavefronts will be same. Energy on the two wavefronts will be same. Why it will be same? Why it will be same? Let answer yourself. Why it will be same? E which is equals to HF. In the last class we have seen F is frequency. Mu also you can write. Don't worry about that. So E which is equals to H times of F. What is this F? Frequency. Alright? So now already we discussed that energy depends on what? Frequency. Now I am not changing any frequency of the source, right? Try to understand it properly and try to write the all points. That will be easy for you to understand, right? So if a source is there, already we discussed if the medium changes or the distance changes, what will be same? Frequency will be same. What will be same? Frequency will be same. So if I go a meter distance, I can set a point. I calculated the frequency there. And I went 2 meters distance from the source. Okay? And I calculated the frequency there. What will get? Will get the same. Is that clear? We'll get the same. In the sense what I can tell, the energy on the two wavefronts will be same. And what about the power? Power also will be same. Why? So power is nothing but rate of work done. So work is nothing but energy. If energy is constant, power also will be constant. Clear about the point? Next, come back to intensity. What will happen to intensity? Generally, practically you can see if distance is for example, consider a source, for example, any bulb, any source. So if you are there nearer to the source, you can see the light with more brightness. If the distance increases, you can see the same brightness. No, brightness decreases. Brightness decreases in the sense intensity decreases. So intensity, so give the name 1 and 2, right? So on which one intensity will be more? On first one the intensity will be more. So intensity I1 is greater than I2. But what about energy? Try to understand, very important point. So most of you people will think these two are related, energy and intensity. No. So energy on the two wavefronts will be same and the power on the two wavefronts will be same. It depends on the frequency, it depends on the source. Intensity depends on the distance. If distance increases, intensity decreases. I think we know a formula, intensity is inversely proportional to R square. Yes or no? Area, pi r square. Or if it is a spherical thing, 4 pi r square, 4 pi constant. So intensity is inversely proportional to R square. Intensity is inversely proportional to R square. Right? Clear about the point? Now, how to apply how to calculate the intensity? It depends on the energy per unit area. Energy per unit area per unit time. So this is the formula to calculate the intensity. Very important. I think the same concepts will get in 11th waves and 11th in the heat also will get in the radiations. In the radiations, same formula again, right? So intensity, energy falling per unit time per unit area. Try to write the complete thing. Energy falling per unit time on per unit area. Energy falling per unit area per unit time. We call it as intensity. So this is the background story for this question. Okay. So now what to calculate? Number of photons we have to calculate. So very important thing and very easy thing. Easy thing. Try to understand the point. It is easy. So what to calculate? Number of photons striking in t0 seconds in this time. So how to calculate? We know intensity I, which is equals to, so what I can write? Energy per unit area per unit time. Energy of what? That is the question. You have to understand again. So energy of what? So we know a formula for energy, hc by lambda. So can I apply hc by lambda here? What is this hc by lambda? Energy of one photon. In the last class we discussed. The differences also I think I said. So whenever you see hc by lambda for energy, that is of energy of the total number of photons or one photon. One photon. So energy of one photon. So here how many number of photons are striking? N number of photons it can strike. So what I can write? N number of photons. N photons. What is the energy? Total energy. Total energy which is equals to nhc by lambda. So total energy I can write as nhc by lambda. So intensity is nothing but total energy. Total energy. What is total energy? It is nhc by lambda. That is the total energy. What is the time? t0 seconds. And what is area? I consider it as A itself. So A. So number of photons we will get from N. So N, which is equals to I lambda A t0 divided by hc. Simple. If you know the concept, it will be very easy. So not lengthy, right? So how many number of photons striking per unit area? How many number of photons striking per unit area? It depends on intensity, it depends on the area, it depends on the time, it depends on the wavelength, it depends on the H and C. So clear about the point? Number of photons striking in area A, not unit area here. I consider area as A. If it is unit area, A value should be 1. So area A I considered, so it should be A. Clear about the point? Right? First you have to understand about the photons more, then a photoelectric effect might be easy for you. You can understand it easily. Okay? So this is the way to calculate the number of photons. So for example, try to calculate this one. Take a minute, pause the video, try to do this one. So here the waves striking perpendicular to the area. See, this is the area. Perpendicular to the area, what is happening? The waves, in a sense, the photons are striking. Now, for example, they will make some angle. Assume is making an angle theta. Making an angle theta. Again, same area. Assume A. Right? So, making an angle theta now with the area it is making an angle theta. Now find the number of photons again in t0 seconds. Question is the same. Find the number of photons in t0 seconds. Find the number of photons in t0 seconds. Right? Try to do positive. Start doing. So the same concept I think in electrostatics we discussed. We can compare the things. So where we can compare? Think about yourself in electrostatics. The same concept we can compare. Where we can compare? Where we can compare? Electric field lines, electric flux. For example, number of field lines are coming in this direction. So assume it has to pass this area, this board. So number of field lines are striking here and they are passing. So flux EDS cos theta. Try to revise for a minute. Okay, EDS cos theta. Now the electric field lines are coming in this direction. In the sense, what is theta? 0, cos 0, 1. In the sense, maximum flux will be there. We know that. Now, for example, the electric field lines are not coming in the same direction. It is making some angle. It is making some angle. If it makes some angle, then what will happen? The number of field lines in the previous case, how much they are entering, and the number of field lines now, what they will enter in this surface or passes through this surface will be same or will be different. Definitely will be different, we know that. So if angle increases, number of field lines entering or passing through the surface decreases. If angle increases, then number of field lines passing decreases. Same concept here. Yes or no? Photon also traveling in the straight line path, right? Particle nature. Try to understand. They will travel in the straight line path. Here, area and the photons are coming in this direction, so all the photons will travel. Yes, but here all the photons will travel. Whatever the photons are coming, all the photons will move from this area. No, getting the point? So in this area passes through this area. Okay, they will strike the surface, but I consider the area A. From the surface they will strike or not. So the number of photons striking that particular area decreases. Now it will be clear for you. I think if angle increases, number of field lines entering or passing through the surface decreases. Same concept here. If angle increases, passing decreases. So how it will decrease? How it will decrease? Always you have to consider perpendicular. We know. So area. Now area is not perpendicular to these photons. Now you have to draw a line which is perpendicular to what? Perpendicular to the photons. Now see, this photon, if I consider a straight line, it will be perpendicular, it will be perpendicular, this one also perpendicular. Clear about the point? Now if this angle is theta, this is 90, right? So if this is 90 and again this angle also will be theta. Clear about the point? If this angle will be theta, I can tell this angle also will be theta. If this angle will be theta, then A, if I resolve into components, it will be A cos theta. Why cos component? If you didn't understand this point, so there in electric flux, EDS cos theta. Why cos theta came? Why cos theta came? If angle decreases, flux increases. If angle increases, flux decreases. In cos component it is possible, or in sin component it is possible. In cos it will be possible. Cos 0, 1. If angle increases, value decreases. Same here. So what component we will get? Cos component we will get. So what I can write? Again say intensity which is equals to energy per unit time per unit area. So what is the energy? It is N hc by lambda. I think this is clear for you. Energy for n number of photons, nhc by lambda. Now what is the time? T0 seconds I said, so it is T. So now instead of area, now what you have to consider? Perpendicular to the photons. Perpendicular to the photons is this component of area. You have to resolve area into components. So it will be A times of cos theta. Now see, we can check this too. Now theta is 0, cos 0 will be 1. Got this? Clear about the point? Now if theta is 90 degrees, nothing will strike this area, they will go like this. Nothing will strike this area, they will go like this. In the sense theta 90, cos 90, 0. Clear about that point? Is it okay? So intensity which is equals to NhC by lambda into T A cos theta. So number of photons we want. So what I can write for number of photons? So it is I lambda T naught A cos theta divided by, so what I can write? HC. Trying to write in the note. Good points to calculate the number of photons. Okay, so N which is equals to I lambda T naught A cos theta divided by HC. So angle, so if it is normal. So is that clear? Next. Next, small topic is there called radiation pressure. We'll see that, and we'll go to Photoelectric. Okay. Okay. So next topic is about radiation pressure. Radiation pressure. Okay. Radiation pressure. So what do you mean by radiation pressure? Try to understand. For example, a simple topic. Nothing. So for example, consider a torchlight. So if I switch on the torchlight, what will happen? The rays will come, light rays will come. In the sense, photons will come. Yes or no? So if I switch on the light rays will come. In the sense, photons will come and they will strike the surface. Already in the yesterday's class we discussed. Okay. So if they strike the surface, what will happen? You can feel some force. Try to understand the point. You can feel some force per unit area. If you consider some area, all that force will be there or not. So why that force will be there? Due to the energy of the photons. Due to the energy of the photons, force will be there per unit area. Force will be there per unit area. We call it as pressure. Due to what that pressure is developed? Due to the radiation of the photons. Due to the energy of the photons. That we call as radiation pressure. Yes, I think if you want, you can switch on your flashlight, yes, of your mobile, and you can place it nearer. So after some time, you can feel like some itching and some disturbances in your hand. I think so. So why? Because due to this radiation pressure, that will be very less, very negligible. So that will be there, negligible, but it will be there. So if you want to calculate that by using what? This concept called radiation pressure. Clear about the point? The pressure developed by the light rays per unit area. The force developed per unit area due to the light rays or due to the photons, we call it as radiation pressure. Right? So if you want to write a point, if a photon or the number of photons falling per unit area, force per unit area, we call it as pressure, and that pressure due to the radiation of the photons, and the pressure due to the radiation of the photons, we call it as radiation pressure. We call it as radiation pressure. So this is nothing but pressure again, force per unit area, nothing new. So we studied in the 11th again about the pressure, yes, in fluids chapter. The same concept here also. Perpendicular force per unit area. That is very important. What is that? Perpendicular force per unit area. Generally, if I tell force per unit area, here also that concept is not up to the mark. The same concept from the fluids we can take. What is that? Perpendicular force per unit area. The same like a number of photons we took from the same concept in electrostatics, the same here also. From the fluids we can take and we can tell the perpendicular force per unit area. If the photons are not striking perpendicular to the area, then we have to resolve to the components already we discussed. Right? So now how to calculate this radiation pressure? Right? How to calculate this radiation pressure? So go to the concept. If you want to calculate pressure, you have to calculate force. If you want to calculate force, you have to calculate momentum, change in the momentum. Right? So if you want to calculate pressure, you have to calculate force. Force, if you want to calculate, you have to calculate the change in the momentum. Okay. So how we can calculate that? Before entering into the topic, very important. Before entering into the topic called radiation pressure, small topics will be there. You have to understand about reflective power. I think again in the heat we studied all these things in the level. Reflective power and absorptive power. Refractive power, absorptive power. But in the heat, one more thing also we studied, that is transmittive power. What is that? Transmittive power. Again in the ray optics also we studied. So if a light ray falling on an interface, what will happen? So reflection will be there, some refraction will be there, and absorption will be there. That refraction is nothing but transmission. according to different names, right? So the refraction we call it as transmission, reflection, and some light will be absorbed. We call it as absorption, right? So now here, how many types of things we have to study? We have to study only about the two types. The transmittive things we are neglecting here. Why? So why you are neglecting? Okay. So consider any surface. We are calculating the radiation pressure, right? So if a torchlight is there, if I switch on, the light will strike the surface, right? So after striking, if it is there on that area itself, then force will be different. If it is coming back, force will be different. So it can't go to the other side. So by striking the surface, it can't go to the other surface. Clear about that point? So reflective and absorptive, both the things we have to consider on any surface to calculate this concept called radiation pressure. Now, so constants I am giving for reflective power. So constants I am giving for absorptive power. Okay. So I think according to your NCERT, only definition is there for radiation pressure. I am extending the topic for 5 minutes. I won't lag much. Only 5 minutes. What is radiation pressure? The pressure on any surface by the photons, we call it as radiation pressure. Simple. Right? Or the force applied per unit area by the photons which strikes the surface, we call it as radiation pressure. Clear about that point? Now for that, what are the topics required? Reflective power and as well as absorptive power. What do you mean by this reflective power? That is nothing but, okay, that is nothing but energy reflected, okay, important point, energy reflected upon energy in the sense number of photons, okay, number of photons reflected divided by number of photons striking the surface. Energy reflected upon energy striking, or number of photons reflected upon number of photons striking. We call it as a reflective power. Next, absorptive power. Energy absorbed upon energy striking or incident or striking. Okay, clear about the point? So, absorptive power, what do you mean by absorptive power? It is nothing but energy absorbed per energy incident or striking. So, reflective power in the sense that is energy reflected upon energy striking. Energy reflected upon energy striking. Is it okay? So, reflective power, energy reflected, energy striking, energy absorbed, energy striking or incident. Now, what you have to understand is the sum of absorptive and reflective always equals to 1. What do you mean by this one? How much, try to understand, how much amount of energy is striking the surface? How much amount of the energy striking the surface is this one? That can be divided into either absorptive power or reflective power. One is what? Then the energy which is striking the surface divided into two parts. So one is absorptive power and either reflective power. There is no other chance. So that's why you can write it as the sum of absorptive and the reflective power, which is equals to 1. Clear about this point? A quick revision, radiation pressure. So how many parts we can divide? We can divide into two parts. The first one is reflective power and the second one is absorptive power. So what do you mean by reflective power? Two chances will be there. If the energy strikes the surface, it can be there itself or it can reflect. Right? So if it is there, in the sense total energy is absorbed by the surface. If it is there, total energy absorbed by the surface. If it is reflected, right? So it comes under reflective power. So energy reflected, energy incident or striking. So energy absorbed, energy striking or energy incident. So the sum of these two which is equals to energy incident. Sum of those two which is equals to energy incident. Sometimes only reflective cases will be there. If R equals to 0. In the sense, there is no reflection. In the sense, only absorption will be there. In this case, only absorption will be there. If A equals to 0, in the sense, the total energy is reflecting. If R equals to 0, total energy is absorbing. What it is trying, it is absorbed. If A equals to 0, total energy is reflected. So R equals to 1, so we can write it as only reflection. If both are there, can I write one more step? Yes. If R equals to R and A equals to 1 minus R, can I write like this? If R equals to R and A equals to 1 minus R, what do you mean by that? Add these two R plus 1 minus R. Minus R plus R cancel. So what do we got? 1. So in this case, what will happen? Both reflection will be there and absorption will be there. Reflection will be there and absorption will be there. Clear about the point? A plus R equals to 1. In the sense what? It is if R equals to 0, A equals to 1, only absorption concept. If A equals to 0, R equals to 1, only reflection concept. If both are there, both reflection and absorption, both we have to consider. Try to write these points, and this is enough for your board level. Little more only we discussed. It's enough. So radiation pressure, right? The pressure exerted on a surface by the photons, we call it as radiation pressure. So generally reflecting, absorption and transmission also will be there. Here transmission we are not considering, only we are considering reflection as well as absorption. 2 points, right? So now A plus R equals to 1, total energy divided into 2 parts. Now R can be 0, A can be 0, or both can be there. So this is the difference. Clear? Okay. Okay. So, can I do a question? Just one question I will do. Yes. So, remaining things I will give for a task for you. You can try it. Okay. Right. So, for example, consider photons striking the surface of intensity I, wavelength lambda, and speed c. Okay. So intensity I, wavelength lambda, and speed c. Okay. So striking the surface, and the condition now, can I take it as A equals to 0? What do you mean by A equals to 0? So absorption is 0. In the sense, try to answer yourself. Absorption is 0, I said. In the sense, whatever the photons striking, those what will happen? They will be absorbed or they will be reflected. All the photons will be reflected by R equals to 0. If R equals to 0, A equals to 0, I can write as R equals to 1. So in the question, any one of these two they will give. If A equals to 0 in the sense, we can write R equals to 1, then how many number of the photons striking, those will be reflected. Okay. Now my question is, find the radiation pressure. Find the radiation pressure in 1 second. Find the radiation pressure acting on this surface in 1 second. Find the radiation pressure acting on the surface in 1 second. Assume the area of the surface is A. Okay? Clear about the question? So what I gave, intensity of the photons I gave, wavelength of the photons I gave, and speed of the photons I gave, and the condition also I gave. Right? Find the radiation pressure in 1 second. What to calculate? Before calculating the radiation pressure, we have to calculate What already I said, before calculating pressure, we want force. If you want force, we want to calculate the change in the momentum. So go to the 11th concept and think about how to calculate change in the momentum. P is momentum, not pressure. This P is pressure. Change in the momentum. What is the formula? Final momentum minus initial momentum. Try to understand. Okay. So final momentum minus initial momentum. Now what happening? Try to see initial momentum in which direction? Downwards. Concentrate. Okay. So photons are striking the surface. What is the initial momentum of the photons? You can revise all the concepts up to now what we discussed and we close everything and we start photoelectric effect. Okay. So the photons striking the surface. What is the initial momentum? We know it as h by lambda. So one photon, what is the momentum? Initial momentum, which is h by lambda. First case. Now reflection is there. In the sense, the same amount of photons will be reflected back. After striking, they will reflect back. Yes or no? After striking, they will reflect back. What is the momentum again? Final momentum, which is equals to again h by lambda. Initial momentum is h by lambda and final momentum is h by lambda for one photon. First I am discussing about one photon, then we can multiply with the other. Don't worry about that. Okay? So initial momentum, final momentum. So now what we want? Change in momentum. So tell me what is change in momentum? Final is in positive axis. So h by lambda. Positive axis, momentum is vector quantity. So positive axis, so positive value. Minus of initial momentum, negative axis. So h by lambda minus h by lambda. Why minus came? Negative axis. So what is change in the momentum? Which is 2h upon lambda. Step by step, try to understand. Very important for the competitive exams. I do only one question. Remaining things you can try if you understand the first question. Okay. So what is calculated? Change in the momentum. H by lambda minus of minus h by lambda. How much is that? 2h by lambda. Now we got change in the momentum. Now force, which is equals to, we know. What is force? According to Newton's second law, rate of change of momentum we call as force. Rate of change of momentum we call as force. Now force which is equals to delta P by delta T. Clear about the point? Now how many number of photons? N number of photons. We want the average force or the net force. How we can calculate? Can I write here? Alright? We'll write here. So net force if I want. So one photon ka change in momentum is 2h by lambda. How many number of photons are there? N number of photons. So force which is equals to n times of delta P by delta T. Right? So in 1 second I said, so F which is equals to n times of change in momentum in 1 second. That we call as average force also. If they ask to calculate the pressure, if they didn't give the time, then you have to calculate the average force, which is n times of change in momentum in 1 second. Try to understand? In 1 second. Now what I can write? N change in momentum we know. Clear? 2h upon lambda. That is nothing but force. So n times of 2h by lambda, which is equals to force. Now what is this n? Number of photons striking in this time. Number of photons striking in this time. That already we calculated. We know how to calculate. Yes or no? So calculate here. Tell me the value. Tell yourself. Find the number of photons. Number of photons in 1 second. So how to calculate number of photons in 1 second? Intensity which is equals to energy per unit area per unit time. Here time is 1 second. Time is 1 second and energy we know. So what is that? Nhc by lambda and A where T is 1 second. So what I can write now? M which is equals to Ia lambda by Hc. Clear? We got N now. So what is that? Ia lambda by Hc. So what is force? Which is equals to IA lambda by HC into 2H by lambda. Right? Any cancellations? HH and lambda will be cancelled. So force is how much? It is 2IA by C. So force is how much? 2IA upon C. So what we want finally? We want pressure. So pressure finally I can write as force per unit area. So where force is how much? 2IA by C divided by A and A will be cancelled. So radiation pressure is 2I upon C. It depends on intensity and it depends on the speed of the light. Try to understand the point about the radiation pressure. Before calculating pressure, we have to calculate the force. Before that, we have to calculate the change in the momentum. So how to calculate the change in the momentum, we know. So case 1, in the sense photons are striking the surface. Case 2, it is reflective case, so all the photons are reflected back. So initial momentum we have to calculate and final momentum we have to calculate, and momentum is a vector quantity. You have to see the direction, then we can calculate the change in the momentum. What is that? 2h by lambda. If change in momentum we know, we can calculate the force. If it is one photon, then direct delta B by delta T. But how many number of photons are striking? N number of photons are striking. So it is N delta B by delta T. Clear about the point? N delta T by delta T. So F average I can write as N times of delta T in 1 second. In 1 second. So force we calculated. So how much 2IA by C? Where N we know how to calculate. It's not new thing for you. So I substituted N and I calculated force. From this force I calculated the pressure. From this force I calculated the pressure. How much we got? 2I by C. Clearly we can tell the pressure, radiation pressure depends on the intensity, depends on the speed. Sorry, speed increases. So what will happen? 2I by C. Intensity increases and the speed, if it is increases, pressure decreases. It depends on both intensity and as well as speed of the photons. Right? My question for you, try to do, then we'll start. So take this question and try to do. Those who are interested, then, so definition is important for you for the board exams, remaining things you can try. It's your interest. Okay. So now my question is, photons are striking the surface, right? Intensity, wavelength, and speed of light. Now we did for A equals to 0 and R equals to 1. Now my question is A equals to 1 and R equals to 0. Find the radiation pressure. And the area is A. Take the question. Find the radiation pressure. Find the radiation pressure. Okay. So find the radiation pressure. Clear about the concept? Try to see the first question carefully and try to follow the same steps. First calculate change in momentum. Then about force. Then calculate N and then calculate the pressure. Try to apply the same method, will be easy. Still more cases are there, we'll see after the board classes. Alright? So this is about the radiation pressure. So now finally try to revise everything up to now what we discussed from the yesterday's class in the dual nature. So we discussed about the photon, properties of the photons, and the story about the photon, who developed it all. Alright? And then how to calculate the number of photons, and then we calculated the radiation pressure. We calculated the radiation pressure. Okay. Now come to the topic. Very important from now, according to your board exams. Keep the heading photoelectric effect. Photoelectric effect. Photoelectric effect. Basics we'll see today. So what is this photoelectric effect? So what we'll study here? Wave nature or particle nature? First doubt you have to get. So in photoelectric effect, this chapter is dual nature. Okay. So this photoelectric effect will gives you the particle nature of the light or wave nature of the light. Particle nature of light. So why? So if you enter into the story, you can understand why. So but photoelectric effect deals with the particle nature of light. And what it will tells to you, we'll see. Okay, so what it will tells to you. So this is an experiment did by Einstein, right? So how he did that experiment? Try to understand the point. Try to understand. So what he did basically is he considered a metal surface. Very basic, very basic. Observations and all we'll see. Just basic thing I am telling. He considered a metal surface. If I consider a metal surface, free electrons will be there. They will move inside the metal surface as well. So free electrons will be there. They will move. Okay, we know that they will move. Right. So if they are moving, what he observed is, if I want that free electron which is moving in the metal surface, what can I do? He thought in that manner. So he considered metal surface. So we know that the free electrons will move inside the metal surface. Okay. Now he want actually. Okay. He want that free electron should come out of that metal surface. What can we do? That we call as electron emission. First topic here we have to understand about electron emission. Keep the heading under this photoelectric effect, basic things. Then we will see the observations. First, what you have to understand is about electron emission. So, what do you mean by electron emission? It is nothing but the liberation. Liberation in the sense bringing out. Okay. So, liberation of the free electrons from the metal surface or from any substance or from the metal surface or from any substance is called electron emission. What do you mean by electron emission? Liberation in the sense bringing out of the free electrons from the metal surface or from any substance. So it is called electron emission. So different types of emissions will be there. We'll see it later. First we'll see what do you mean by photoelectric effect. So on the way, whatever the things we will get, everything we will study. So don't deviate the things. Whatever the thing we will study, we will get the things here, we will study about that and we will go back. So types, everything are there, but we will see it later. Don't deviate it from now. Okay. So what do you mean by electron emission? Electron emission is nothing but bringing out of the free electrons from any substance or from the metal surface. We call it as electron emission. Now what he is doing actually, try to understand. What he did actually, so he sent some photons. Try to understand. He sent some photons. So while sending some photon, he is sending in the sense some energy will be there with the photon. Okay. So that energy is there. So if we send a photon with some energy inbuilt, okay. So what it will do actually, he did some experiments. Is that clear? So a photon which strikes the surface. So while striking the surface, here for example an electron is there. So what will happen actually? What will happen actually? All the things we have to study here. So what will happen, we will study later, don't worry about that, up to there try to understand, okay. So a photon is moving, it strikes the surface, in the sense it is having some energy, with that energy only it strikes the surface. While striking the surface, what will happen? It can bring out the electron out of the surface or not. How it can bring? What factors are important to bring that electron outside? All those things he observed and we have to study in this topic called photoelectric effect. Right? So try to write the definition. Photoelectric effect. This photoelectric effect is a phenomenon of, photoelectric effect is a phenomenon. Okay. This is a phenomenon of Okay, this is a phenomenon of bringing out. Okay, so bringing out the electrons or free electrons, actually bringing out of the free electrons from the metal surface, so phenomenon of bringing out of the free electrons from the metal surface by of metal surface. How we are bringing out of the metal free electrons from the metal surface? By falling, by what? By falling photons, or by striking the photons on it. By falling or striking, whatever, both are same. Striking the photons on it. On it, what do you mean by it? Metal surface. So photoelectric effect is nothing but it is a phenomenon of bringing out of the free electrons from the metal surface. How we will bring? By striking the photons on it with a particular frequency. That is important. If you want, you can write with a particular frequency. Exactly. Without this definition is not 100% correct. With a particular frequency. So what do you mean by this particular frequency? We'll see in the observation. This is the introduction part. What do you mean by electron emission? Is that clear? So what is photoelectric effect actually? So I discussed some story here, and after that, this is the definition of the photoelectric effect. Now coming back to my story again, it will be interesting. Try to write the points according to the board level. We discussed all the definitions up to now. Now come back to the story, which is very interesting. Interesting topic. Try to write all the points one by one. First point. What he did actually, right? So what is photoelectric effect? Is that clear? Metal surface, photons strike the surface, and electrons will come. Is that easy? Photons strike the surface and electron came out. Not that much easy. Whatever the photons strike on the surface, for example, 1000 photons strike the surface, 1000 electrons will come. All the questions I am raising, try to write all the questions, not a problem. So 1000 photons strike the surface, 1000 electrons will come. 1000 photons strike the surface, 1 electron will come. It depends on what? Everything we have to study here, right? So here what I am telling you have to write those points. Why? Because this is an experiment, experimental observations. Whatever the things I am telling, so it is an experiment, we can't show here. You have to understand the things, right? Okay. So first point. So let me discuss practically. So for example, assume two students are there, you and your friend. Assume you and your friend, two members are there. So one day what I said to you to bring two sources of light, two bulbs. Two sources of light in the sense what? Two bulbs. So you bought one bulb and your friend bought another bulb. Okay, so two bulbs. Right, understand. Bulb 1 and bulb 2. So you bought bulb 1 and your friend bought bulb 2 of different companies. I said that in that condition while bringing, I always said that. So it should be of same power but of different companies. Same power, I think we know. So on the electrical appliances, you can see 100 watts. If it is ACs or if it is big instruments like 1000 watts, right? So 100 watts bulb I said you to bring, but of different companies. Clear about the point? So now bulb 1 is of 100 watts and bulb 2 is also having 100 watts, but of different companies. Company 1 and Company 2. Now what I did? I consider the same metal surface. Try to understand this point. If you understand this point, remaining things will be easy again. Okay? So consider the same metal surface. Same metal. Same metal. Okay? Same metal surface. And bulb 1, bulb 2, what I did? So I switched on the bulb. What will happen? The photons will strike the surface. And bulb 2 I switched on. Try to understand. Same metal surface. Same metal. Same metal. Okay? So both are of same metal. And bulb 1 I switched on. And bulb 2 I switched on. So now, what should happen actually? So if bulb switched on in the sense, photons will strike the surface. If photons strike the surface, electrons should come out. That is the story of photoelectric effect, right? So if we switch on the light, photons will go and it will strike the surface and electrons should come out. So now, try to understand this point. This is my assumption. You have to understand this. Now, bulb 2, assume if I switch on, electron came out. Assume electron came out from the metal surface. And from the bulb 1, if I switched on, electron didn't come out. From bulb 2, electron came out, and from bulb 1, electron didn't come. So what is happening actually? What happened? So why from this electron came out and why from this electron didn't come? What happened actually? Those points we have to understand first. So first, all the things we have to do. So 100 watts, same power. So same energy. So if same energy, electrons on both things should come out, but it is not coming. So once if electron won't come out, for lifetime it won't come out. Try to understand these points. If once the electron didn't come out, for the lifetime with this source, the electron won't come out. For sure. Okay? Now, sir, when will get for this source the electron out of the surface? Why it is not coming? Why it is not coming? In the sense, concentrate. This 100 watts is the total power. So if I talk in terms of energy, the total energy of the source. Very important point. This 100 watts on both sides is what? Is the total energy. Is the total energy of the photons. 100 watts, 100 watts. If I convert into energy, that is the total energy of the photons. Now try to understand two different companies. Mind you, that is important. Okay? So now the electron is coming out from the surface doesn't depend on the total energy. Very important point. Electron coming out from the surface doesn't depends on total energy. It depends on, very important, it depends on the energy of one photon. It depends on very important points. You have to digest those points, okay? So, the total energy of the photons. What is this 100 watts? That will gives you the energy, total energy of one photon, total energy. Now, electron from this bulb came out and this bulb didn't come out. So, finally, I can tell that. So, electrons coming out of the metal surface doesn't depend on the total energy. Why? If it depends on the total energy from this bulb 1 also, electrons should come out, but it is not coming. It came? No. In the sense what we can conclude, electron coming out doesn't depend on the total energy. It depends on the energy of one photon. Okay, sir, you are telling all those things. Come back and tell when this system will produce the electron. When will this system will produce the electrons? When in the sense, what I did. See now, so about energy we discussed. Okay, now this 1000 watts, right, next point is clear up here. It depends on the energy of one photon. How we can conclude this depends on the energy of one photon according to the experiment is, Next, what I did, if electron is coming out in the sense, what I did in the sense, what the scientist did, he changed 100 to 1000 watts. He changed from 100 to 1000 watts. Same company, but electron didn't come. Now 1000 watts to somewhere around 10,000 watts, they changed. The same company. Again, the electron is not coming out. In the sense, something is there. Something is there. So that's why they gave this points. What is that? It depends on the energy of one photon. So now if I change 100 to 1000 or 1000 to 10,000, what will happen? Total energy we are changing. We are not concentrating on the energy of one photon. So that's why electron didn't come outside. Now in the next class, we have to discuss about, okay, so if energy we are changing, power we are changing, so energy we are changing, so electron is not coming outside. Then what are the other factors to discuss? Other factors to discuss. Now what are those factors to discuss? Try to think. We have to discuss about wavelength and frequency. So we discussed about energy. We changed the sources of the same company from 100 to 1000, 1000 to 10,000. Still electron is not coming out. Then what are the other factors we have to discuss when the electron will come out from this bulb? One. So those factors are about wavelength and frequency. So about this, we will see in the next class. Try to understand the points in the photoelectric effect what we discussed, definitions. After that, the first point, only one point we discussed up to now. What is that? We can say two sources, and in one source electron came out, and the other source electron didn't come out. So why it happened? It depends on the energy of one photon, not on the total energy. Alright? So other factors we have to discuss in the next class is about lambda and frequency. After discussing about this, then we will go into the next points. Further, in what factors it will discuss, how many number of electrons will come out. All those things we'll discuss in the next class. Okay? Thank you. Bye.